There's a forest in the mountains of southeastern Kazakhstan where, if you walk through it right now, you'd see wild apple trees taller than houses, dropping fruit in every color and shape you can imagine. Some sweet, some so bitter they'd turn your face inside out. Geneticists have traced the DNA of literally every apple you have ever eaten, every Honeycrisp, every Fuji, every bruised gas station Red Delicious back to this one forest and to one wild species, Malus severici. Your grocery store apple has a great-great-great-grandmother, and she's still standing in the Tian Shan Mountains. That's the kind of thing I love about this fruit. It's the most ordinary food in your kitchen, bland enough that we use it as the default icon for healthy eating. And it's also got one of the richest, weirdest, most well-researched molecular stories of anything we eat. Today, we're doing a full deep dive on the apple, where it came from, what's actually inside it at the molecular level, what the clinical research really shows about cholesterol, cancer risk, and gut health, where the evidence gets overhyped, who should actually be careful with apples, and exactly how to buy, store, and eat them to get the most out of every bite. I'm Dr. Dan. This is Molecules Matter, and today the molecules in question are hiding under the skin of the fruit sitting in your fridge right now. Welcome back to Molecules Matter with Dr. Dan. Today's food is the apple, Malus domestica, and I promise that even if you think you know everything about apples, you don't. Here's a preview of where we're headed. We'll cover why an apple is genetically closer to a rose than to a strawberry, and what that actually means. We'll break down the specific phytonutrients, quercetin, catechins, chlorogenic acid, phloridzin, ursoic acid, that show up over and over in cardiovascular and cancer prevention research, and where in the apple each one actually lives. We'll look at real randomized controlled trials on apples and cholesterol, not just epidemiology. We'll talk about why baking an apple might actually make some of its antioxidants more available to your body, not less. We'll cover the dirty dozen pesticide list controversy, apple seeds and cyanide. Yes, we're going to go there. And a genuinely surprising drug interaction involving apple juice that most people have never heard of. And we'll end with the single most practical thing you can do this week to get more out of this fruit. Let's get into it. The apple's origin story is one of the better documented ones in all of agriculture, thanks to genome sequencing work done over the last 15 years or so. The domesticated apple, Malus domestica, traces its primary ancestry to a wild species called Malus severici, native to the Tian Shan mountain range. The area spanning southeastern Kazakhstan, Kyrgyzstan, and into western China. Wild groves of this ancestor apple still grow there today near the city of Almaty, whose name is sometimes translated as father of apples. Humans have been eating wild apples for an extraordinarily long time. Archaeological evidence points to apple consumption going back more than 8,000 years. But the domestication process, where the fruit was selectively bred toward larger size and sweeter flavor, is generally dated to somewhere between 4,000 and 10,000 years ago in that same Central Asia region. From there, the apple hitched a ride west along the Silk Road. As it traveled, it picked up genetic contributions from a second wild species, the European crabapple, Malus sylvestris, through natural hybridization. So the apple in your kitchen today is really a genetic blend, mostly Central Asian wild apple with a meaningful assist from European crabapple picked up along the trade routes. As for who grows the most apples today, the map has shifted dramatically from where apples originated. China now produces about half of the entire world's apple crop, by some estimates nearly 10 times the volume of the United States, which sits in the number 2 spot. Turkey and Poland round out the next tier of major producers, and in the U.S., Washington state alone accounts for the majority of the domestic commercial crop, with Michigan and New York also being significant producers. So the fruit that started in a remote mountain forest in Kazakhstan is now a global commodity crop grown on nearly every temperate continent on Earth. Apple trees are genuinely temperate zone crop. They need cold, and that's not incidental. It's a requirement written into their biology. Apple trees go dormant in the winter, and they need a certain number of chill hours, meaning cumulative time spent at temperatures below about 45 degrees Fahrenheit, but above freezing, in order to properly break dormancy and flower well in spring. Depending on the variety, that requirement ranges anywhere from around 200 chill hours for low chill varieties bred for milder climates, up to 700 or even 1,000 plus hours for classic high chill varieties. This is exactly why you don't see commercial apple orchards in, say, Florida or coastal Southern California. It just doesn't get cold enough for long enough. Once the tree breaks dormancy, it wants a fairly specific growing season. Daytime temperatures in the mid-60s to mid-70s Fahrenheit for active growth and photosynthesis, a frost-free window of roughly 150 to 180 days to let the fruit fully mature, well-drained soil, and full sun. Harvest timing spans a wide window depending on variety. Early season apples come off the tree in late July and August. Mid-season varieties peak in September and October, and late-season storage varieties can be picked as late as November. That's part of why apple season in the U.S. really runs from late summer all the way through Thanksgiving, even though most of us think of it as a strictly an autumn thing. One more detail worth knowing. Apple trees grown from seed don't reliably produce the same variety as the parent tree. Apples have a wildly variable genetics, so a Honeycrisp seed won't grow into a Honeycrisp tree. Every apple variety you buy is propagated by grafting a cutting from an existing tree onto rootstock, which is also how growers control tree size and disease resistance. Let me run through a handful of facts that make the apple stand out even among fruits. First, apples are botanically part of the rose family, Rosacea, the same family as pears, peaches, plums, cherries, almonds, and yes, actual roses. Early 20th century botanists formally reclassified apples and pears as subfamilies within Rosacea based on flower structure, which is 5 petals, a cup-like blossom shape. So next time someone hands you a bouquet, remember it's a distant cousin of your afternoon snack. Second, apples float, and the reason is genuinely fun. About a quarter of an apple's volume is trapped air within its cellular structure, which makes the fruit less dense than water. That's the actual science behind bobbing for apples. Third, the phrase, "an apple a day keeps the doctor away," is younger than you think. Language historians trace an early version, "eat an apple on going to bed, and you'll keep the doctor from earning his bread," to an 1866 Welsh folk saying, with the modern phrasing showing up in print by the 1880s and becoming common by the 1920s. It's a catchy piece of folk wisdom, not an ancient medical text, though, as we'll see, the underlying idea holds up better than a lot of folk sayings do. Fourth, an apple tree takes 4 to 5 years after planting before it produces its first fruit, and a full-size standard tree can take 8 to 10 years to reach real bearing maturity, which is a big part of why apple orchards represent such a long-term agricultural investment. And fifth, the world record for the heaviest apple ever grown, according to Guinness World Records, was a 4-pound, 1-ounce apple grown in Japan in 2005, more than 4 times the weight of a typical grocery store apple. Let's now talk about the molecular composition of apples. And let's talk about macronutrients. A medium apple, about 180 to 190 grams with the skin on, contains roughly 95 calories, about 25 grams of carbohydrate, around 4 grams of fiber, less than half a gram of protein, and essentially no fat. Nutritionally speaking, an apple is almost entirely a carbohydrate food. But it's the type of carbohydrate that matters here. A meaningful chunk of that 25 grams is fiber, which behaves very differently in your body than the same amount of sugar from, say, apple juice or candy. That distinction, Fiber-wrapped natural sugar versus free sugar is a theme we'll come back to throughout this episode. Let's talk about micronutrients. Apples aren't a micronutrient powerhouse in the way that, say, a leafy green or a citrus fruit can be, but they contribute meaningfully to a few things. A medium apple provides around 14% of the daily value for vitamin C, roughly 5 to 6% of the daily value for potassium, and about 5% for vitamin K, along with small amounts of manganese, copper, B vitamins, including B1, B2, and B6. None of these numbers alone are going to make headlines. What makes the apple's nutritional profile interesting isn't the vitamin and mineral panel, it's what comes next, which is phytonutrients and bioactive compounds. This is the heart of the show, and with apples there's a lot to cover, because this fruit has one of the more extensively studied polyphenol profiles of any commonly eaten produce item. The headline compound is quercetin, a flavanol, a subclass of the broader polyphenol family. Quercetin is almost exclusively concentrated in the apple's skin, not the flesh, and it's one of the most heavily researched flavonoids in nutrition science, studied for its antioxidant activity and its ability to modulate inflammatory signaling pathways in cells. Next are the catechins and epicatechins, flavan-3-ols, chemically related to the compounds that make green tea famous. Apples, particularly the skin, contain meaningful amounts of these, along with their larger polymerized cousins, which are called procyanidins, and these are strings of catechin units linked together. Procyanidins, in particular, have been a major focus of cardiovascular research, which we'll get to in a moment. Then there's chlorogenic acid, a phenolic acid that's also the star compound in coffee. In apples, it's present in both flesh and skin and has been studied for effects on glucose metabolism and antioxidant capacity. Apples also contain a compound almost unique to them among common fruits, phloridzin, a dihydrochalcone concentrated heavily in the peel and even more so in the leaves and bark. Phloridzin has a curious pharmacological history. It was actually the molecule that led scientists to first understand how the kidney reabsorbs glucose, research that eventually contributed to the class of diabetes medications called SGLT2 inhibitors, which are now blockbuster drugs. That's a case of an apple molecule indirectly shaping modern pharmacology. Finally, there's ursolic acid, a triterpenoid concentrated specifically in the waxy cuticle of the apple's skin. It's part of what gives apple peel its slight structural toughness. Ursolic acid has drawn laboratory interest for potential effects on muscle tissue and metabolism, though this line of research is early stage than the flavanol work and needs some more research behind it. The unifying theme across nearly all of these compounds is this: they are concentrated disproportionately in the skin. Study after study comparing peeled versus unpeeled apple tissue finds that the peel carries a large majority of the fruit's total antioxidant capacity and flavonoid content. If you take away one molecular fact from this section, make it that one. We'll return to it when we talk about how to eat an apple for maximum benefit. Let's now talk about how cooking and preparation change the molecules. This is one of my favorite sections to cover because the conventional wisdom, raw is always better, doesn't fully hold up here, and the reality is more interesting. First, the peeling question. Because quercetin, catechins, and phloridzin concentrate so heavily in the skin, peeling an apple doesn't just cost you fiber. Some estimates suggest you lose roughly half the fruit's fiber and a substantial share of its antioxidant capacity right along with the peel. If you're peeling your apples out of habit, that's the single biggest easy win you're leaving on the cutting board. Second, cooking. The relationship between heat and apple polyphenols is genuinely nuanced rather than a simple cooking destroys nutrients story. Some research on quercetin bioavailability has found that light cooking can actually improve how much of certain compounds your body ends up absorbing, likely because heat softens plant cell walls and releases bound polyphenols that would otherwise pass through less accessible in raw form. That said, the cooking method matters enormously. Boiling is the worst offender, because flavonols and phenolic acids are water-soluble and will happily leach straight out of the fruit into the cooking liquid. So, if you're making stewed apples and discarding the water, you're pouring a chunk of the nutrition down the drain. Baking, roasting, and light sautéing behave very differently, because there's no water for the compounds to escape into, and if you bake the apple with the skin on, which I'd recommend, you retain both the fiber and the concentrated skin-based flavonoids. So, a baked apple, skin on, is a genuinely reasonable way to eat this fruit, not a compromise. Third, freezing and drying. Freezing has a relatively modest effect on polyphenol content compared to fresh, though texture obviously changes. Drying concentrates sugars and some nutrients simply through water removal, but dried apple products often lose vitamin C, which is heat and oxidation sensitive, and commercial versions frequently add sugar. So read labels here. Apple juice and cider, meanwhile, strip away essentially all of the fiber and a large share of the skin-based polyphenols during pressing and filtering, leaving you with mostly the fruit sugar without the structural and phytochemical package that comes with the whole fruit. This is a recurring pattern in nutrition science. Processing that removes fiber tends to change a food's metabolic effect much more than removing a similar amount of any single vitamin. Let's now talk about nutrient pairings and absorption. Apple polyphenols are generally water-soluble compounds, which means, unlike fat-soluble vitamins A, D, E, and K, they don't require dietary fat for absorption in the same way. That said, there are still some useful pairing principles. Some research suggests that consuming polyphenol-rich foods alongside a small amount of healthy fat, say apple slices with almond butter or a drizzle of olive oil in a salad with apple, may support absorption of certain flavonoid compounds and also slows the glycemic impact of the apple's natural sugars, keeping blood sugar rise more gradual. On the flip side, there's an absorption interaction worth knowing about that runs the other direction. Apple juice, along with grapefruit and orange juice, can inhibit intestinal transport proteins called OATPs, organic anion transporting polypeptides, which are involved in absorbing certain oral medications from the gut. We'll cover the clinical specifics of that in the cautions section, but the takeaway for nutrient pairing purposes is that apple's absorption effects aren't limited to its own nutrients. The fruit can also change how well your body absorbs certain drugs taken around the same time. Section 8. Let's talk about human and cellular clinical research. This is where we separate the marketing from the evidence. So let's go compound by compound and study type by study type. Starting with cardiovascular research, because this is genuinely the strongest body of human clinical evidence for apples. A randomized controlled crossover trial published in the American Journal of Clinical Nutrition had mildly hypercholesterolemic adults, these are adults with high cholesterol, eat 2 apples a day and found significant reductions in total cholesterol, LDL cholesterol, and triglycerides, along with improvements in a marker of vascular inflammation called ICAM-1 and better blood vessel function. This isn't a single isolated finding either. A systematic review and meta-analysis pooling multiple trials on apple or apple polyphenol consumption found consistent improvements in LDL cholesterol, increases in protective HDL cholesterol, and reductions in C-reactive protein, which is a marker of systemic inflammation. Separately, concentrated polyphenol extracts from a specific Italian apple cultivar called Anurca have shown cholesterol-lowering effects in human trials that researchers describe as comparable in magnitude to certain statin medications at the doses tested. Though I want to flag clearly that this is a concentrated extract, not something you'd get from eating a normal apple, and it comes from a smaller body of research rather than the broader apple and cholesterol literature. The proposed mechanism across this research involves apple procyanidins and other polyphenols affecting cholesterol metabolism, partly through effects on liver cell mitochondrial activity, plus general antioxidant and anti-inflammatory effects on blood vessel walls. Evidence strength here? I'd call this well-established and consistent for whole apple consumption's effect on cholesterol and inflammatory markers in human trials, with the caveat that not every trial has shown identical results. One earlier study, for instance, found no effect on endothelial function specifically, even while lipid markers improved in other studies. Nutrition research on whole foods rarely produces uniform results across every single trial, and that's normal, not a red flag. Now, cancer risk. And here I want to be careful about the distinction between different types of evidence. Laboratory and cell line studies have shown that quercetin, apples, triterpenoids, and oligomeric procyanidins can slow proliferation of cancer cell lines from the colon, lung, and breast, though mechanisms including antioxidant activity, modulation of how carcinogens are metabolized, anti-inflammatory signaling, and promotion of programmed cell death in damaged cells. That's cellular evidence. Real, but it doesn't by itself improve anything about eating apples affecting cancer risk in living humans. Moving up the evidence ladder, observational epidemiological studies in humans have found associations between regular apple consumption and reduced risk of certain cancers. A case-control study on colorectal cancer found that eating one or more apples daily was associated with roughly a 50% lower odds of colorectal cancer compared to non-apple eaters. And other observational research has linked regular apple intake to reduced lung cancer risk as well. I want to be precise about what this evidence does and does not show. These are observational, case-controlled, and cohort studies, which can identify associations and generate strong hypotheses, but they cannot establish causation the way a randomized controlled trial can. People who eat an apple a day differ from people who don't in lots of ways beyond apple consumption, and researchers do their best to statistically adjust for that. But it's never perfect. So my honest read of the evidence: promising and consistent cellular mechanisms plus consistent but not proof of causation human observational associations. This is a case where the mechanistic story and the population level pattern point in the same direction, which is reassuring, but it falls short of the kind of definitive human trial evidence we have for cholesterol effects. Finally, gut health. Apple pectin, the soluble fiber concentrated particularly in the skin and core, has been shown in fermentation studies to be a genuine prebiotic, meaning gut bacteria break it down and produce short-chain fatty acids like acetate, propionate, and butyrate, compounds linked to gut barrier health and anti-inflammatory effects in the colon. Research has specifically shown apple pectin promotes beneficial bacterial groups, including Lactinospiraceae and related short-chain fatty acid producers. Most of this specific fermentation and microbiome shift data comes from in vitro fecal fermentation studies and animal models, rather than large human clinical trials. So I'd call this promising, mechanistically sound, and consistent with what we know about fiber generally, but still earlier stage compared to the cardiovascular data. Another really interesting area of research with apples is skin health. There's several clinical studies showing that apples can provide glowing skin and they have a beauty from within component to them. Let's now talk about who should be cautious and the risks of interactions. Let's talk through this responsibly because apples are safe for the overwhelming majority of people, but there are a few genuine considerations. First, allergies. Oral allergy syndrome. People with birch pollen allergy frequently experience cross-reactive itching or mild swelling in the mouth when eating raw apples, because a protein in apple flesh resembles a birch pollen allergen. Interestingly, this reaction typically disappears when the apple is cooked, since heat denatures the protein responsible. So, a birch pollen allergic person who reacts to a raw apple can often eat apple pie without any issue. Second, and this genuinely surprised me when I dug into the research, apple juice has a documented drug interaction through a mechanism similar to the well-known grapefruit juice interaction, though it works in the opposite direction on absorption. Apple, orange, and grapefruit juice can inhibit OATP transport proteins that are responsible for absorbing certain oral medications. The antihistamine, fexofenadine, brand name Allegra, is the best studied example, and clinical research has shown apple juice can reduce fexofenadine absorption by 40 to 70%, meaning your allergy medication may barely work if you take it with apple juice. The practical guidance from that research: take phenylfexidine with water and separate it from juice by several hours in each direction if possible. Third, FODMAPs and digestive sensitivity. Apples contain a combination of excess fructose and sorbitol, both fermentable carbohydrates that fall under the FODMAP umbrella. And this combination is a well-documented trigger for bloating, gas, and abdominal discomfort in people with irritable bowel syndrome or general FODMAP sensitivity. Research using the Monash University FODMAP testing protocol has found that a much smaller portion, roughly 20 to 25 grams, which is about 1/8 of a medium apple, is tolerated by sensitive individuals, while a full apple is likely to trigger symptoms. If you have diagnosed IBS, this is genuinely one to be aware of, even though apples get marketed as a universally safe health food. Fourth, apple seeds. Yes, they contain a cyanogenic compound called amygdalin, which can release small amounts of cyanide when the seed is chewed or crushed. An intact swallow seed generally passes through without releasing much of anything, but the numbers here are reassuring. Each seed contains a tiny fraction of a milligram of releasable cyanide, and researchers estimate an adult would need to chew somewhere in the range of 150 to several thousand apple seeds, depending on the study and apple variety, to approach a genuinely toxic dose. Accidentally swallowing a few seeds from your apple core is not a health event. Fifth, for most people on blood thinners like warfarin, apples themselves aren't a major vitamin K concern the way leafy greens are, since their vitamin K content is modest. But, as with any food, consistency matters more than elimination if you're on anticoagulant therapy. Talk to whoever manages your medication about your overall dietary pattern rather than apples specifically. So, how much should you eat? Based on the body of research we just walked through, 1 to 2 medium apples a day is a genuinely well-supported target. It's the amount used in the strongest cardiovascular trials, showing cholesterol and anti-inflammatory marker improvements, and it aligns with the intake levels associated with reduced cancer risk in the observational research. There isn't strong evidence that going well beyond that produces additional benefit. This looks like a case of diminishing returns past a couple of servings a day, and eating 5 or 6 apples daily would just be added sugar load without meaningfully more phytonutrient benefit. Plus, it would start crowding out dietary variety, which matters for its own reasons we'll discuss later. For most healthy adults, 1 to 2 apples a day, skin on, is a reasonable evidence-aligned target, not a floor you need to hit every single day, but a solid default. Let's talk about organic, variety, and other sourcing notes. Apples have a complicated relationship with pesticide residue rankings. In the Environmental Working Group's most recent shopper's guide, apples showed up lower on the list than in several previous years, around 9th place, following a methodology update that now factors in pesticide toxicity rather than just residue count and frequency. But regardless of exact rank, apples do consistently test with a higher frequency of pesticide residues, commonly detecting residues on a large majority of conventional samples, including fungicides like pyrimethamine and flutoxidil and diphenylamine, a chemical historically used to prevent post-harvesting browning during storage. Given that apples are eaten skin on far more often than, say, a banana or an orange, and given that the skin is exactly where the good phytonutrients concentrate, Apples are a reasonable candidate for buying organic when it fits your budget. You're eating the part of the fruit most likely to carry both the beneficial compounds and the residue. On variety differences, this is genuinely one of those cases where cultivar matters. Comparative studies of different apple varieties have found meaningful differences in polyphenol profiles. Red Delicious has tested highest in total phenolic and flavonoid content in some studies. Granny Smith has consistently ranks well for fiber and certain flavonoid classes, and Fuji has shown notably high catechin content in others, while quercetin specifically tends to run higher in Red Delicious, Jonah Gold, and Golden Delicious than in Fuji. The honest summary is that there's no single best variety across every compound, although I personally prefer Red Delicious and Granny Smith. But the trend, darker skinned, more tart, and more deeply colored varieties tend to trend higher in total polyphenol content than very mild pale varieties. So if you want to maximize phytonutrient variety, rotating between 2 or 3 different types rather than always buying the same one is a reasonable practical strategy. Fresh versus frozen versus dried versus juiced. Fresh, whole skin on is the gold standard for retaining the full fiber and phytonutrient package. Frozen apple products hold up reasonably well nutritionally. Dried apples concentrate sugar and calories per bite and typically lose vitamin C, so portion awareness matters. And many commercial dried products add sugar. Apple juice and cider, even unfiltered versions, lose a majority of the fiber and much of the skin-derived polyphenol content during pressing, leaving mostly sugar and water. It's a fundamentally different food from a whole apple, nutritionally speaking, and shouldn't be mentally filed in the same category. Let's do a quick round of myth versus fact. Myth: apple seeds will poison you if you accidentally swallow a few from the core. Fact: as we covered, you need to chew through well over 100 seeds to approach a toxic dose, and an intact swallowed seed poses essentially no risk. Myth: cooking an apple destroys all its nutritional value, so raw is always better. Fact: it's more nuanced than that. Boiling does leach out water-soluble polyphenols, but baking or roasting a skin-on apple retains most of its fiber and antioxidant content, and some research even shows improved bioavailability of certain compounds after light cooking. Myth: apple juice is basically the same as eating an apple, just in liquid form. Fact: juicing strips away nearly all the fiber and a large share of the skin-based phytonutrients, leaving primarily sugar and water. It's not nutritionally interchangeable with the whole fruit. So let's talk about how it compares. The most natural comparison food for the apple is the pear, its close cousin in the rose family. Gram for gram, pears actually edge out apples on fiber, roughly 3.1 grams per 100 grams for pear versus about 2.1 grams for apple. And a whole medium pear can provide around 6 grams of fiber, meaningfully more than a medium apple's roughly 4 grams. Vitamin C content is nearly identical between the two. Pears also run somewhat higher in copper, vitamin K, and folate, while apples contain roughly double the vitamin A and beta-carotene you'd find in a pear. Calorically, the two are close, with pears running very slightly higher. So the honest comparison is, if fiber quantity alone is your priority, pears have a modest edge. But apples bring a deeper and more thoroughly researched polyphenol profile, particularly around cardiovascular outcomes. This is much more, both are an excellent pick based on what you're optimizing for, then one fruit clearly outperforms the other. So if your need state is more heart health, then I would go for the apple. Let's talk about sustainability and environmental footprint. Apple production's environmental footprint depends heavily on how the orchard is managed. Conventionally managed orchards have measurable carbon footprints. Research puts conventional systems at roughly 0.14 kilograms of CO2, which is equivalent per kilogram of fruit, which is largely driven by fertilizer production and irrigation. But sustainably managed orchards using practice like no-till soil management, cover cropping, and compost-based fertilization instead of heavy synthetic inputs have been measured with dramatically lower and in some studies even negative carbon footprints, meaning the orchard system was acting as a net carbon sink rather than the source. Water use is a real regional concern in some major apple growing areas. Intensive cultivation in water-stressed regions like China's Loess Plateau has been linked to long-term groundwater depletion, given the crop's deep root systems and high water demand as a perennial tree crop. The practical takeaway: apples grown under sustainable, low-input orchard management carry a meaningfully smaller footprint than conventionally intensive operations. So, certifications and knowing your grower's practices can matter here if environmental footprint factors into your purchasing decisions. The bigger picture. Here's what I want you to take away from all this molecular detail. The apple is a genuinely well-researched, cardiovascular supportive, gut-friendly fruit with a distinctive and valuable polyphenol profile concentrated largely in the skin. But no single food, including this one, is a magic bullet. The same research showing apple polyphenols improving cholesterol and inflammatory markers comes from studies where apples were part of an otherwise reasonable diet, not a diet built entirely around apples. The cancer risk research, in particular, is a great reminder to hold the evidence at the right strength. Promising cellular mechanisms and consistent population-level associations are genuinely meaningful, but they're a different tier of evidence than the well-established randomized controlled trial data we have on cholesterol. The apple earns its reputation, but it earns it as one of a strong contributor to an overall pattern of eating. Fiber, phytonutrient variety, minimizing ultra-processed food, not as a standalone cure for anything. What's the practical takeaway? 2 simple actions for this week. First, if you've been peeling your apples, stop. Eat the skin. That's where the majority of the quercetin, catechins, and phloridzin actually live, along with roughly half of the fruit's fiber. Second, try rotating varieties instead of always grabbing the same one. A Granny Smith one week, a Red Delicious or Fuji the next. Since different cultivars bring meaningfully different phytonutrient profiles, and variety itself is a low-effort way to broaden your intake of beneficial compounds. That's the apple. 8,000 years of history, a wild ancestor still growing in the mountains of Kazakhstan, and a genuinely deep bench of clinically studied molecules hiding under a very ordinary-looking pill. If you learned something today, subscribe, leave a review, and share this episode with someone who still peels their apples. The molecules matter because you matter. I'm Dr. Dan, and I'll see you in the next episode.